Well, we have three problems to do. The first is find the domain of this one. F of x equals the square root of 4 minus x squared. Well, because of this x squared, it's not as simple as just saying 4 minus x squared is greater than or equal to 0 and solve. Here's what we'll do. We'll find the zeros first. We'll put 4 minus x squared equal to 0. And then adding x squared to both sides, we get 4 equals x squared, but we like the variable on the left, so x squared equals 4. So x equals, using the square root property, plus or minus 2. So now we know what the zeros are. We'll draw a number line and hash mark it -2, hash mark it 2, and then we'll sign the graph. We know x can be 2 or -2, because then we'll just have the square root of 0, and square root of 0 is 0. Anyhow, let's pick a point in this interval, a value in this interval. How about -10? Replacing x with -10, you square -10, you get 100. 4 minus 100, that's going to be negative. Let x be 0. Hey, we'll get the square root of 4, which is positive. Let x be something like 10. We'll get a negative again up there. So we have to choose the positives because we can't take the square root of a negative and get a real number. So anyhow, there's our guy, and in interval notation, that's -2, 2, 2, bracket, and bracket. Or another way to write it is domain equals the set x, such that -2 is less than or equal to x, which is less than or equal to 2. Now let's go on to question 2. And question 2 says, given that we know what the graph of f of x equals f of x, excusez-moi, equals root x looks like, and just as a reminder, it's a parabola, the top half of it, as it opens to the right. There. That's the graph of root x. But we have to find the graph of g of x equals square root of 9 minus x plus 2. Let's ignore the 2 for the moment, so I'm just going to cover that up for the moment. Now, what's the domain of the square root of 9 minus x? Well, to find that, we set 9 minus x greater than or equal to 0 and solve. So subtracting 9 from both sides, we get minus x is greater than or equal to -9, so multiplying through by a negative we get x. And now we have to flip the inequality as less than or equal to 9. And so we'll go over here, x and y. We'll go over here to 9. And x is less than or equal to 9, so here we are at 9. This point right here is 9, 0. And we know this works, and at least 9's in the domain, and all values of x less than 9. Well, let's find the y-intercept, and if we replace x with 0, we'll get a y-intercept of 3. 0, 3. And we could graph this, but now we have to take into account our friend Mr. 2 here. That means raise every one of these y values up 2. So now we're at 9, 2. And now we can go ahead and graph, and if we add 2 to 3, we'll be at 0, 5. And notice we just took this graph, flipped it over, raised it up 2, and shifted it to the right 9, and there's our graph. Now we have one more to do, number 3. And so we've got to solve this x plus 1 equals the square root of 3x plus 7. So now let's square both sides to get rid of this radical. And when we square this, that means we have to FOIL it. And when we FOIL it, we get x squared plus 2x plus 1. And that's going to equal 3x plus 7. Now we'll subtract 3x from both sides. And so 2x minus 3x is going to be a negative x. And now we'll subtract 7 from both sides. And 1 minus 7 is a minus 6, and we've got 0 on the right. So this factors, and we get x, and we need a 2 and a 3, and the 3 gets the negative, 2 gets the positive. So the solutions to this are x equals minus 2 or 3. Now we've got to check those, because that doesn't mean these are the solutions to what we were given. And notice, if we replace x with negative 2, we get negative 2 plus 1 is negative 1, and the square root of a real number is not going to equal negative 1, so we'll throw out the 2. So that means x equals 3. And if we replace x with 3, we'll get a 4 here, and we'll get the square root of 16 here, which is 4, so it works. And we're done.